Hi, I'm Maxime Dupart, creator of the Shadow World plugin. Welcome to the presentation of the 1.1 update. First of all, I'd like to start by thanking the members of our Discord community who've made several valuable contributions already. They've shared their experiments, their feedback, and suggestions. It's been really cool. We've got some really nice conversation going, and I'm looking forward to have your feedback about the new update. The plugin has been claimed around 19,000 times on the marketplace so far. See, we have like 15 reviews, so it's been really cool to see to read some of your feedback. So if you've taken the time to experiment with it, feel free to join the Discord. There's a link in the marketplace storefront. Leave a review, share your feedback, and it can really help not only promote the plugin but also shape the development of new features. 1.1. There's a lot of new features, improvements, optimizations, so let's get to it. I'll start by the interface, the detail panel of the world. In world settings, I've added a new entry named the LED dimensions meters. So you can now have the information of the various dimensions of your LEDs. So here's so that just LEDs is 15 kilometers, 7, 3, 1, up to down to 234 meters. In spawnables, I've added more options to the to customize the spawning of the assets. So you now have the ability to apply vertical offsets, and a couple of new options like receive decals, two-sided lightning, distance field lightning, dynamic indirect lightning. Okay, I also added a new option named the collision only at proximity. So it's I've taken this. I've made a small drawing here. So to explain how the assets are spawning. So right now around the camera you have a set of grids. You can define the number of grids you're computing here, number of region per quadrant side. So here it's at 3. It means that I'm gonna go up to 3 on the grid here. So I'm gonna generate kind of a circle of grids around the camera, on which I'm gonna compute the asset positions with the new option of collision only at proximity. You have the option to enable collisions only on the first ring, up to the first ring. So you have the grid near the camera as well as the first layer of grids that are going to have the collision enabled. And it's an optimization which allows you to, for instance, you can go quite crazy on the number of grids you're computing in the distance. You can make a huge forest up to the horizon, but you'll only compute collisions near the camera. So it's a way to optimize the performance while building large worlds. Okay. In world collision, I've renamed this parameter here. I've named it now compute collisions to be in line with what we can find here. Compute cache, Heightmap, and normal. So if you've worked on a project previously with a plugin, you might have to put back the collision material here, which can be found in the material functions in this folder. It's specific to each world, because you have to specify the defined function here. So you might have to put back this material here, because the name has changed, so it will be reset to a null pointer. And here you can see a new parameter which is named platform capabilities. It's only relevant if you're working for smartphones, so Android or iOS. Otherwise, you can leave it as it is. Okay. So first of all, a new ability of the with the update, you can now import 16 bits 8 maps. So if you were to just drop a 16-bit 8 map into the editor, the content folder, you wouldn't be able to import the full range of informations. You have to use a specific tool. That's why when you are importing 8 map into the landscape has its own set of input entry to import your 8 map. So you can pick this blueprint here, you drop it in a world. You can locate your 8 map. So it's right now it's compatible with the raw file format as well as PNGs. So you select your raw. If it's a raw file format, the file does not provide the dimensions of the texture. So I know this one is 2048 by 2048, so I specify it. If it were a PNG, I can extract the information from the PNG file, so it will be automatically filled here. I then specify a folder for the 8 map, so I'm going to call it demo 8 map or imported 8 map. Okay, and I'm gonna name the 8 map demo import. Okay, I click import. So in the content folder, I now have the imported 8 map and my new texture, which is gonna store the 16-bit information within 2 channels. So you have the red channel and the green channel, which are both gonna store 8 bits of the original 16-bit information. So the information is split between these two channels. Once you have imported this 8 map, you can use it on a new tool that has been added to the brush system, which is the 8 map brush. So you have a demonstration of the 8 map brush just here. The 8 map brush is actually reading this 8 map here. Oh, maybe a new one. Okay. Oh, it's the same one. Yeah, of course, the same one. The 8 map brush is reading the information stored in the 8 map you just imported. So what it can do is use the 16-bit information and adjust the terrain height. So you can move it, you can rotate it. So I did it actually mostly in Blueprint. So right now in Blueprint I'm setting the your information, the rotation information of the blueprint to the shader, to the material managed by the brush. You can check the 8 map brush here. So the 8 map brush is checking, the ability to change to the UV offset. UV offset, I'm setting the yaw of the brush, a fade amount. So it might be hard to see. Yes, it's to adjust the blending. Okay. I have a radius. So right now, as you see, it's mostly done in Blueprint. The only thing that I'm sending automatically with any brush system is the location of the brush. The location of the brush is always done in C++, so you can see it's extremely smooth. The only reason you might see some stuttering on the while I'm rotating is that there is a time frame rate to define for the blueprint updates that you can change here. Right now I'm updating the blueprints only 5 times per brush update. So I'm updating the brush 20 times per second, and I'm updating the blueprint once every 5 updates. So I'm updating 4 times per second. Okay, so I can choose to update every time. It's gonna be much smoother. Oh, oops, brush imports. We didn't care about this one. Yeah, you can see it's much smoother now. The Heightmap brush is showcasing 2 things. Not only now can you import 8 maps and read them in the Heightmap brush, you can also write into the data layers of the landscape from the brush system. It's quite a big deal because right now what I'm able to do with this Heightmap brush is I'm able to not only change the terrain but also to write the flow maps, the flow map of the Heightmap that I've computed from the my terrain generator. So it can be Gaia, World Machines, World Creator. So you can see I've added the flow map here. And the flow map, the brush now has the ability to write into the data layers of the landscape. So the landscape has a data layer that I've created here. It's named 8 layer. The 8 layer is just a completely useless layer, which is writing only black into every channel. So it's completely useless right now. It's named 8 layer. In the brush system, I've checked this box here to inform the system that I want to draw into the layer system. I've selected the 8 layer, and on the 8 layer I'm going to apply this material. So in this material I'm getting the layer here. So it's named data layer. It will always be named the data layer. You don't have to copy 8 layer here. It's you select one layer, and it will always be named the data layer here. So once I've picked the data layer, I'm gonna write into those 2 channels, the red and the blue channel, this information. So in the red channel, I'm gonna read the flow map here. So I'm reading the flow map, and I'm using a way to fade the flow map in the blue channel. And I'm writing this into this layer. This layer can then be used in the material of the landscape. So right now I'm using it to change the material. If I go into the landscape material, which is using the cache, you can see the data layer here. I'm grabbing the red channel, and using this red channel I'm playing around with the ID used to pick a material in the texture to the array. So I'm playing around when I'm reading the red channel here. If the red channel is to 1, you can visualize the actual red channel here. You can see the flow map. So if the flow map is equal to 1, I'm changing the ID red from the texture to the array to 1. So I'm going to read the second material. Okay, it's quite a big deal because now not only can you use the flow map, the information written in the data layer to change the material, you can also use it like in the demo map. you can use it to adjust the spawning of assets. Shadow world content, maps, Heightmap. So in this map, I'm using the data layer to adjust the location where I'm spawning this grass element. So you can do exactly the same with the brush system now. You can have a brush which is adjusting the terrain for, instance, for a road, and you can pick the sideway of the road and define assets to spawn near the road, or you can adjust the terrain and define location to spawn assets. And you can move it completely dynamically. You can add brush at runtime, remove brush, and it's completely dynamic, and it's pretty powerful. Okay. So the brush can now write to the data layer. There's a new brush system, and you can import Heightmap. I forgot to mention that I added 2 new options for the rendering. For the rendering, you can now choose 2 cinematic oriented options for the rendering of the world. You can now render with over 1,000 and 2,000 vertices per patch. So if I check the wireframe, I'm gonna adjust the density here. Okay, so I'm almost already going into this sub-pixel per triangle. And I'm not even playing with the number of, with the resolution of the cache here, so I can go even further. So the flow map is written to the cache, the data layer. The data layers have the resolution defined by the cache system. So if I drop the resolution of the cache, you can see the information is actually becoming blurrier and blurrier. If I increase the cache resolution, you have much more information, but it's always the same number of vertices. So you can really play with. You really have a range of scalability, a range of options to optimize the rendering, and we still have the same number of vertices here. I just increased the resolution of the texture. And you can see the budgets used by the render target here. So if I go from 2 to 4, and go from 3050 megabytes of video RAM to 90. Okay, so it's a brush system. It's a Heightmap import, and new options also that I've added is for the spawnables. The spawnables now have the ability to improve their location as you get closer to them. So the spawnables are using the cache, the maps you're generating, so the Heightmap and the normal maps, to define if they can spawn or not. So let's say you've defined the range of terrain slope for an asset to spawn. It's going to use the normal map you've computed far into the distance, let's say, and it's going to read it. And if the slope is within the range you've picked, the asset is going to spawn, even if it's very far away. The thing is, if it's very far away, the Heightmap has a resolution of maybe one texture element per 3 meters. So the precision at which you are spawning the assets is rather low. So if I'm jumping to this asset I've spawned into the distance, it's gonna have a low quality precision. So what it's doing now is, as a closer I'm getting to an asset that I've spawned into the distance, the better the location is going to be. So it's going to recompute its location and adjust it. So you don't have any asset spawning on top of the ground, even if the asset has been spawned very far away. So I can spawn trees up to the horizon. And the closer I get, the better the location of the trees are going to be adjusted. So you don't have any flying asset above the ground. And you can check here. Position can be adjusted with LOD. It will tell you which is the lowest LOD, which means the highest quality cache is going to be able to read to adjust its location. So the grass right now I'm using is going to be able to use the LOD1 to adjust its location. So it's a LOD which is of dimension of 468 meters. Okay, so I can spawn grass up to the horizon, and the closer I get, the more likely it's going to be able to use the LOD number 1. Okay. Another update about the plugin, which is quite a big deal, is that it's been tested with several platforms, and it's now completely compatible with Windows, Mac, Android, both on OpenGL and Vulkan rendering, and iOS. So we've been testing this with iPads, with Galaxy S9, and it's all working. It's all performing great. I've been like locked 60 FPS running this exact map I'm showing you right now, and everything is running great on smartphones. All right, so here are the updates about 1.1. Thanks for watching.